All right, so we're looking at slopes today. And slopes, the letter that represents slopes for us or will represent slopes for us is the letter M. The formula for the slope is y2 minus y1 over x2 minus x1. Or you can do y1 minus y2 over x1 minus x2. Only thing you have to remember is that if y2 is used first on top, then make sure you use x2 first on bottom. Same thing with y1. If you use y1 first on top, make sure you use x1 first on bottom. And then we have rise over run. And we will use that relationship when we actually try to graph using these slopes. All right. So x1 and y1, x1, y1, and x2, y2 are going to be any 2 points on the line. Let me write that together right here. So any 2 points on the line that you have. And so that's this diagram right here, just generally, if you have a line, any 2 points on the line, get those coordinates and you can calculate the slope. And the slope is exactly what it sounds like. You're talking about like the slope of the mountain, or slope of a ramp, or the slope of a roof. Talking about the incline, the steepness, and it's just putting a number on how steep or how slanted a line is. All right, scroll up.
Could you wait 1 second?
Yep.
You good?
All right, thank you. So if we want to find the slope, let's say they give us the 2 points, -2, -4, and 3, -5. Establish which one you're calling point 1 and which one you're calling point 2. And I'm going to do it both ways first, just to show you that either way you'll get the same answer. And what I mean by both ways, you're talking about this way and then this way. But when you normally do it, you only have to do it one way, because like I said, you'll get the same answer regardless. So looking at the first one, we're going to do y2 minus y1. So y2 is -5. Y1 is -4. So that's why we have -5 minus -4. Make sure you don't lose a negative. A lot of times when you have to plug in -4 or a negative number, people will lose a negative because there's a negative also, in the formula for that minus sign. So make sure you don't lose a negative. And then we'll do x2, which is 3, minus x1, which is -2. So we have 3 minus -2. Negative to a negative turns positive. So that's why we have -5 plus 4, 3 plus 2. And that'll be -1 over 5. All right. Hey, why did I go so far down? Okay. All right. And then if I were to flip them and do y1 minus y2 over x1 minus x2, I have -4 minus -5 over -2 minus 3. And that would be 1 over -5, which is the same thing as -1/5. So you get the same answer regardless. Just have to make sure you stay consistent Once again, if you do y2 first on top, make sure you do x2 first on the bottom. Or if you do y1 first on top, make sure you do x1 first on the bottom. All right. Any questions?
I'm so sorry. Good morning. I'm a little late. I don't know exactly what you were saying. I'm just getting here. Can you repeat it again?
Oh, it's just we're plugging in values, finding the slope. We have our slope formula right here.
Okay.
And we're plugging in our values from these 2 points.
Okay, let me get myself together. I'm sorry.
It's okay.
All right.
I believe we're about to do it again in the next one. So let's go here. So let's do that again. So the next one, we have 5 and -6 as our first point. 8, 3 as our second point. So y2 is 3. Y1 is -6. So that's why we have 3 minus -6. Then x2 is 8 minus 5. All right. So we have 3 minus -6, 8 minus 5. Once again.
What was the problem? Was this the problem right here? M equals X?
Directions were to, write in blue, find the slope. Yeah, and they give you those 2 points. And so that means you have to use this formula right here, y2 minus y1 over x2 minus x1. All right. So 3 minus -6 is 3 plus 6, which is 9. 8 minus 5 is 3. 9 divided by 3 is 3. So your slope would be 3.
Yeah, I'm real lost. I don't know what.
Oh, well, we'll double back. I'll double back for you later. But yeah, you missed the first part when we first,
All right, so I'm gonna just sit here and listen.
Yeah. All right. We'll talk. I'll come back for you.
Okay. I'm like, wait a minute, I'm so lost right now. Okay.
Probably, yeah. After I let everybody go, you might catch on by the time we finish
Okay.
doing this. So yeah. So everybody okay before I scroll up? All right. So basic behaviors of your slopes. So we have 4 basic behaviors. First one, if your line is going up as it goes to the right. In other words, if you look at this, it's going up. Your slope is positive. As it goes to the right, if it's going down, your slope is negative. Once again, your slope, M, is a numerical value that represents the slant or incline of your line. And then for the next two, if you have a horizontal line, your slope is 0. And if you have a vertical line, your slope is undefined. All right.
1 second, please.
Mm-hmm.
You can go.
All right. Thank you. Anybody else before we scroll up? All right. So parallel lines, the lines that never touch or cross, they will have the same incline. And if that's the case, that means they have the same slope. Perpendicular lines, lines that create a 90-degree angle at their intersection, and the slopes are negative reciprocals of each other. So we'll talk about it, what that means exactly in a second. Just give you a chance to write this down. Slopes have to be negative reciprocals. All right. Oh, I don't think I mentioned, right here I got this arrow, just reminding you that unless it's said in the words, or you see that symbol, you cannot assume that you have 90 degrees. So you always got to see either that symbol, that red box, red square, or it has to say somewhere that the lines are perpendicular. All right. So now what does it mean to be a negative reciprocal? So you look to the left over here, these are just reciprocals. In other words, you're just talking about flipping your fraction. If I have 4/5, the reciprocal of 4/5 is 5/4. If I have negative 10 over 7, the reciprocal of that would be negative 7 over 10. If I have 8, the reciprocal of 8 is 1 over 8. So you're just flipping the fraction. Now, if you're talking about negative reciprocals, you're talking about opposite signs as well. So, another word for negative is opposite in mathematics. So if I have 4/5, the negative reciprocal would be negative 5 over 4. If I have negative 10 over 7, then the negative reciprocal will be 7 over 10, positive 7 over 10. And then if I have positive 8, the negative reciprocal will be negative 1 over 8. So you're talking about the negative reciprocal, which is what we need as the slope of perpendicular lines. You need the opposite sign, and you need to flip your fraction. All right, questions on that? Okay. All right. So the next one, we want to give the slope of the line that's parallel and the one that's perpendicular to the given slope. So what I mean by that, let me erase this so we can walk through it. So if they give me my slope is 3/5, what's the slope of the line that's parallel to that? And then what's the slope of the line that's perpendicular to that? And so down here in the red, I was just pointing out that this symbol means parallel, and this symbol means perpendicular. All right. All right, so if we go back to what we said about parallel lines, they're going to have the same incline because they never touch and never cross each other. So if the slope of my original is 3/5, and I want a line that's parallel to that, then the slope of a parallel line would also be 3/5. Remember, they're going to be the same. Parallel lines will have the same slope. Now, perpendicular lines would be negative reciprocals. So remember, the reciprocal is to flip. Negative means to use the opposite sign. So I will have, excuse me, -5/3 as a slope of a line that's perpendicular to my original slope or original line, which is 3/5. All right. Questions before we do another one?
One sec.
All right.
I have
I
a
guess
question.
I'm listening.
One of those scenarios, they'll always give you that base number and ask you what the parallel slope is or the perpendicular is.
Yeah, in this type of exercise, yes, you will already have your original one and then say, okay, what's the parallel line to that one? And then what's the
Okay.
perpendicular? Yep.
Okay.
So in the next one, if I have -11/9 as my original, then one that's parallel to it would be still -11/9. Remember, it has to be the same. If it's going to be parallel and then perpendicular, you flip it and use the opposite sign. So that would be +9/11. All right. Oh, I just did one more. We have 1/7. Parallel would be the same thing, 1/7. And then flip it, -7/1, which is -7. So I just did one more just to reemphasize the concept. All right, before we go into graphing, questions on those relationships. All right. So remember in that first part of introducing your slopes, the last part of it, the last part of the relationship was rise over run. I said we would use that in order to graph. So your slope is equal to rise over run. That rise means that you would make a move of up or down, and then the run is right or left. So rise over run. So your slope is basically going to be directions for you to use in order to create your line or graph your line. All right, and those directions will be
Repeat that
basically.
again. I don't understand that. Can you say that again?
Oh, well, you might not understand until we actually do it. So, but they're directions. They're directions for us to be able to graph our line. So, and those directions will be given by your positive moves and your negative moves. So, your positive moves are going to be up and right. Your negative moves will be down and left.
Okay.
Hmm.
Thank you.
Yeah, when we put some numbers to it, though, it'll make more sense.
Okay.
All right, can I scroll up? All right. So what I mean by positive moves, let's say if I have positive 3 over positive 4 as my slope. So if my numerator is positive, that means I'm going to go up 3. And if my denominator is positive, that means I will go to the right. In this case, it would be right 4. Both top and bottom are positive, so that's up 3, right 4. Now, if it's negative, if one of the numbers are negative, let's say we have negative 5 over 7. Now, this negative only applies to one or the other. You cannot give it to both because you know negative over negative is positive. So that negative is not going to both, it's either one or the other. I always say just give it to the numerator. But if you want to give it to the denominator, you'll still get the same value. So it says if you give it to the numerator, that'll be down 5. It's a negative 5 over a positive 7. So that'll be down 5 to the right 7. Or if you decide to give the negative down to the 7 down bottom, that would be a positive 7, a positive 5 over a negative 7. So I will go up 5, left 7. But either way, you will get the same result. Like I said, if you were, let's say if I'm looking at this right here, and basically we're going to have a point. If I were to go down 5 and then right 7, I'd be this way. But then if I go back to that point and go up 5 and left 7, I'll still be here. But notice I will still get that same line. So it doesn't matter whether you give the negative to the 5 or give the negative to the 7. As long as you follow these directions, you'll still get the same line.
Oh.
All right. Questions before we move off of that? All right. So slope intercept form. Y equal to mx plus b, where m is our slope and b is our y-intercept. And once again, and I had a box up there just because I want to emphasize the idea that what's in front of x is the slope. So in other words, let's say if I have y equal to 2x plus 1, the slope is 2, not 2x. Sometimes people would write that the slope would be 2x. So I'm just trying to make sure we don't include the x as a part of our slope. Notice our slope all the way up to this point has been just a number, not a number in the letter. And sometimes, like I say, some people will write 2x as the slope. And of course, my math lab will mark that wrong because the slope does not have a variable involved. Your slope is just a number, and it's what is in front of or attached to the x. Okay. So in this form, if you have solved for y or you have y by itself, then it is going to be, and to simplify, it's going to be in the slope intercept form. So you have to make sure that y is by itself on one side of the equation in order to pick out your slope and your y-intercept. So simple example, if I have y equal to 2/3 x plus 1, and I want to know, Mess with that. If I wanted to know what the slope was and what the y-intercept was, then I can just pick them out, because once again, y is already solved for. So that means what's in front of x is my slope, and the other number is my y-intercept. All right. Any problems with that? All right, so there's another one right there. If I have y equal to negative 18 over negative 8 over 13x minus 5, your slope is negative 8 over 13. Your y-intercept is negative 5. All right. So let's look at the directions to graphing. So we're going to plot the y-intercept first. Notice I said with underline, because it is important. We're going to plot the y-intercept first, and then we're going to generate another point from the y-intercept with the slope. So we don't go back to the origin. Remember, we go to the origin when we have another point. Your slope is not a point, and so a lot of people make that mistake. You don't go to your origin in order to generate a point with your slope. You generate a point from the y-intercept. And so you'll see what I mean in a second. Just give you guys a chance to write. All right. So let's look at this equation right here. Y equal to 2/3 x minus 1. Our slope is 2 over 3. Both of them are positive, so they're going to be positive moves. I will go up 2, right 3. And then our y-intercept is negative 1. But our y-intercept as a point, don't forget the characteristic of all y-intercepts is that x is equal to 0. That's always the case. All right. So if you're writing that y-intercept negative 1 as a point, that's going to be 0, negative 1. All right. Any questions so far? All right. So now the first move is to graph the y-intercept, which is 0, negative 1. Then from the y-intercept, so this is what we're talking about. You go to this point and generate another point from the with your slope. You do not go to your origin. You go to your origin, start from your origin with your point. But remember, your slope is not a point. It's going to generate another point from the y-intercept. So you go to your y-intercept and go up 2, and then right 3. And now you have your line.
So the first initial one, when it says 0, we know that always sits on the axis, right?
Exactly. You got it. That's always going to be on your axis. I'm trying to draw my line through both points. I keep missing. One more time. Yep, still missing. There you go. All right, questions on that before we do another one? All right. Negative 1 over 4 x plus 3. So what's in front of x is our slope, negative 1 over 4. So the 1 is negative, the 4 is positive, so I go down 1, right 4. Oh, get my line back. And our y-intercept is 3. And don't forget, since it is a y-intercept, that means the coordinate or the component, the x component of the point is going to be 0.
Wait, can you, so for graphing the down 1, right 4, wouldn't you go down and then to the right 4? How come it's above on the top, that point?
What you mean?
Like when you graph it, you start it from the middle, right? And then you go down 1 and you go to the right. Oh, are we doing the y-intercept first?
Yes, got to grab the y-intercept first. Mm-hmm.
Right.
Yeah. So like she mentioned, we're going to graph the y-intercept first. So we start there, we go 0, 3. So we go nowhere for x, and then we go up 3.
Okay.
And then from the y-intercept, we go down 1, and then right 4. That'll be the line. Questions? Any questions? Make sure we're all right.
Yeah, I got a question right here. When you go, so the first intercept is going to be a 0 of, x origin of 0. So we're going to go up 3, you said. And then you subtract like you do in regular math, subtract the negative 1.
You can look at it that way, but you if you're just talking about movements,
yeah,
you're gonna go down 1.
So just automatically down 1, and then over 3, 2. So this is that gonna form a not a parallel line, a horizontal line? No.
Well, hold on. So let me make sure I understand where you're coming from. So we graph this 0, 3 first, which puts us right here. And then from this, now, because remember, all we're trying to do is graph. All we're trying to do is graph this line. And so that the line that represents this equation is what we're trying to graph. So point that 0, 3 goes right here. Now from 0, 3, right now, all we have is a point. If we graph that, all we have is 1 point, but we need a line. So to generate another point, so we can have our line that represents this equation, we use that slope, and we can go down 1 and then to the right 4. And that gives us this point. Yep.
Got it.
Which helps us to draw the line that represents this equation. And then if I wanted to, I can keep generating points by going down 1, right 4, down 1, right 4, and it'll keep giving me points on this line.
Oh, okay. All right. Thank you. I think I was missing. I was getting confused. I don't know.
Okay. Let's do another one. How about, if I have 5x. So let's say if I have 5x plus 2y equal to 8. I don't know if you guys will get one like this, but it's worth exploring. So remember, we need y to be by itself in order for us to be able to pick out our slope and our y-intercept. So we need to solve this equation for y. All right, so we're going to minus 5x from both sides. So if I minus 5x from both sides, that'll be 2y equal to negative 5x plus 8. Now divide by 2. And
What
also,
if you divide them by the 2? The 8? Or just 8? How do you do that?
that's what I was about to give you.
Oh.
That this 2 has to go into both parts. And that'll be negative 5x over 2 plus 8 over 2. No, I'll just keep going down. And so now we're looking at negative 5 over 2x plus 4. So this is the equation that we need to look at in order to be able to pick out our slope and our y-intercept. All right, any questions? Everybody okay so far? I need more room. All right, so what's in front of x is our slope. The other numbers are y-intercept. So we have a negative 5 over 2. So that means down 5, right 2. And then our y-intercept as a coordinate will be 0, 4. All right, questions? So
We need to do a few more of these.
let's use that to graph. So remember, don't forget you graph that first. So that's going to be 0, 4. And then from your y-intercept, so from the y-intercept, I go down 5. So that's 1, 2, 3, 4, 5. And then to the right 2. And that's the line.
Okay, wait, you said you went down 5?
Mm-hmm.
Why does it seem like you're going up?
Now, what do you mean? So now,
Like go ahead.
because I graphed the 0, 4 first. So 0, 4 is right here.
Oh, Okay.
And then I go down from 0, 4 and to the right 2. And that's how I
So I
got
was
here.
doing it backwards.
Mm-hmm. What you say? You said doing it backwards?
I was doing it backwards.
Oh.
So should which way should we do it? Should we always graph the Y first or the X?
You always graph you're not graphing the Y, but you're graphing the y-intercept, which is the point. And so when you look at this point right here, that's called your y-intercept. So it's not just Y, but it's the y-intercept. The y-intercept is just another name for a point. That's where your line intercepts the y-axis. And so when you look at that, of course, you give an account for this X first, which is 0 though. That's why you don't move off of your your y-axis. And then you go up 4.
Okay.
So I just think you're doing it, but you're doing it to the wrong thing first.
I think so. Yeah, because I'm getting confused.
Mm-hmm. So you got the right concept as far as your directions are concerned. Yes, when you're graphing a point, you are supposed to make your X move first, but then your Y. But I think because I called this the y-intercept, that you're thinking you're not supposed to do that first. So terminology though, that y-intercept just represents, it's just another name for a point. Yeah, but it has nothing to do with what you do first and all the stuff like that. It's just another direction for your point. Another name for a point, I should say. And
Okay,
so,
not really a X or Y. It's just a point itself.
Right, exactly.
Okay.
So you always graph the y-intercept first. When you're trying to graph using your slopes, you always graph the y-intercept first, which is 0, 4. That's a whole point. It's not a move, it's a whole point. And so
always grab the point first, basically, is what you're saying.
Okay. And then from your point, you use these directions. You go down 5 and then right 2.
Okay. That makes me understand that better. Always graph. Okay. Thank you.
And just going to recap, just even going back to the one we did here. That's how we got this. We graphed this point first, which was 0, 3. And then from that 0, 3, we went down 1, right 4. And so it's always going to be on this y-axis. Before we grab 0, negative 1 first. And then from the 0, negative 1, we went up 2 and then right 3.
I'm getting this confused when we graph the points.
Yeah,
you know how we gotta find the different points on the graph? I
yeah.
think that's getting confused.
So that's a different method. Remember, you had 3 different methods.
Right.
And so this is our 3rd method that we're talking about.
Oh, so I'm kind of on the right page.
Yeah, you just confusing a little bit of the direction, but yeah, I knew what you were talking about. All right. Any other questions? So let's see what this next one is. That's 5, 6. I mean, that's it for chapter 6. I mean, not chapter 6, chapter 5. Let me do that. Let me check out one thing, guys, before I write something else. Oh, it's not coming up. All right. Just trying to make sure. I got the right thing before I say this. For anybody who came in late, don't forget that Super Bowl question if you want to shot at some extra credit.
What was the question? I'm sorry, I was late.
I sent the email. It's in the email. I was just saying that don't forget to check
Check
that
that.
email. Yeah.
Okay.
So question in camp. It's just who you think going to win the Super Bowl. That's it.
I don't know. It's hard. It's gonna be a tough one.
So I told him.
Funny. Somebody gonna be mad.
Mm-hmm.
Because Kansas City is something, but I don't think they ready for that boy. You know, them old heads, you know, we put in work, they be underestimated.
You funny. So what I would do here is, because we have one more section, and then we'll be out of chapter 10. So don't forget, you need to contact Mr. Davis. And you can CC me on that. But Mr. Davis, when you're ready to take a test, J.L. Davis at tcc.edu. So you contact Mr. Davis when you're ready to take that test. We already are done with one, so one test has already been posted. Well, all of your tests have been generated, just that they're password protected. And so, our first chapter's test, I think it was chapter 9, whatever it was that was set up, that's already, we've already covered all the lecture on that. Now this next one, which is chapter 10, we only have one more section left. And so I will hold off on that, as far as talking about it today. We'll do that next class. But, this weekend, if you have questions, I don't have to take up the whole class to talk about that section. I can talk about that section and still have time left over in which we can answer questions. So take time out to get in there, see if you have any questions that are, that will be generated over the weekend through my math lab or any of the assignments that you're making an attempt on, so we can make sure that you're ready to take your test. And then from there, you will schedule a test with Mr. Davis. Like I said, you can CC me on that, so that if there are any issues, if there are any communication issues, I can, say, hey, well, I see that she did try to contact you on this day or that day or whatever. And, you just have, a timestamp on that from more than one spot. Questions on that. Oh, also let me say this: once you contact them, wait for Mr. Davis to contact you. And when I say them, it's a tutoring center, and then he will send you directions on, what to do. Those directions aren't going to come from me. You just CCing me so that you'll have a reference point to say, hey, Mr. Tucker, I tried to contact Mr. Davis. No one has responded. That normally doesn't happen, but just in case it does happen, it's not just your word against his or your word against whoever's answered that email, because it might not even be him, it might be one of the tutoring people on staff. So at least you have another point of reference as to when you did send that request out. But like I said, those directions though on how you will be tested, once again, you're going to be tested from home. You're not going up to the tutoring center. They're going to send you directions. You have to come in, y'all will talk about when is the good time for you and all that good stuff. And then you will log on at whatever time you guys agree upon. Then from there, there'll be other directions and you will go from there.
I don't know if I asked you this question, but yes. Are we allowed to use a calculator?
Should be able to use your calculator, not notes though.
Okay.
If I'm not mistaken, there should be the simple 4-function calculator. Now I don't believe you're allowed to use the TIs, the ones that cost like $80 and stuff like that. But a simple 4-function calculator, most definitely you should be able to use.
Okay.
Yeah. Anything else? Anybody else? Okay. All right. So, if you have any questions, feel free to, email me. Enjoy the Super Bowl. Have fun with it. Like I said, make that pick. And just like I said, just adding a little spice to the Super Bowl. Give you something to root for, something to look forward to in the paper. If anybody reads the paper anymore, come Monday morning. If you don't watch the Super Bowl, So outside of that, you guys have a great weekend. Be safe. I'll see you on Thursday. I'll see you on Tuesday, right? And have a good one.
All right then. Thank you.
All right. Now, Miss Christina, did you need this right here? I know this was the
I need the
beginning.
beginning part of whatever we did. I'm
Yeah.
talking about, okay, thank you.
Yeah. I know. That was like she gone. I thought she needed
You
it.
know?
This is it
No,
right
I do.
here. So I'm gonna stop the recording.